queue as a linear data structure and its application. Now, similar to the stack, queue can also be implemented as a static data structure as well as dynamic data structure. Now, statically, queue can be implemented using array. Dynamically, queue can be implemented. Queue is implemented using linked list. So both the programs we will be looking at as and when we discuss queue as a data structure. So first of all, we will discuss the concept of the queue. Then we will discuss implementation aspect of the queue using array as well as linked list. Then we will discuss various applications of the queue. Now let me explain logically what is queue and what are the different types of queues and how queue is different from the stack. Now remember, stack is the linear data structure in which elements are inserted and deleted from only one end. And that end we call it as a top. Now this is the stack, or so when I write it like this, you can imagine this is the stack whose one end is fixed and only one end is open. And these are the slots in the stack. Elements are inserted and deleted from the same end. There is no way that you can insert from in between and on. So this is not allowed in stack. Suppose you want to insert A, B, C, D. So A will get inserted at index 0. Then B will get inserted at index 1. C will get inserted at index 2. D will get inserted at index 3 and so on. And then we want to delete. When we want to delete, we call it as a pop. So when you call pop, automatically D should get deleted. So next top is C. So top is what? Top is the index of lastly inserted element. So when D is deleted, so from A, B, C, lastly inserted element is C. So top is 2. So index of lastly inserted element. So when you again perform pop operation, so C gets deleted. So only A and B remains. So among A and B, lastly inserted element is B. So top is 1. So top is 1. So B is deleted and so on. So before we understand queue, we must understand stack, because both are related data structure. Both are linear data structure. The only thing is stack is having one end closed, another end is open, while queue is having both end open. Now again imagine the application of stack in the bus. In the bus, you have only one door open, front door open, and we get into the bus and occupy the seats. The one who enters the bus occupy the seat here, last seat, and subsequent passengers entering the bus occupies the seats, and the one who enters last occupies the front seat. The person who is sitting on the front will be the first to get out from the bus. So stack works based on the principle of last in, first out, because only one door is there, and the one who has gone into the in first will be out last, or the one who has gone last, one has come in last, one who has come in last will go out first. So stack is first in, last out. So now let us understand the queue. Now imagine same bus is having two doors open. and one door is designated as incoming door, and second door is designated as outgoing door. So incoming door, this passengers can only enter through the bus only through this door, and outgoing door means passenger can. So this is the driver here. So you are accustomed to this kind of buses. Passengers get into the bus from the back door, and they get out of the bus from the front door. So no passenger can get out from this door, or no passenger can get into this door. This is not allowed. This is not allowed. Only this door is for incoming purpose, and this door is for outgoing purpose. Now, when bus is having such kind of configuration, passenger gets into this bus, and the one who enters into the bus occupies the front seat. They sit here. Then next who gets into the bus occupies this seat, and so on. Passenger will go on occupying these seats. Means the one who has get into the bus first has occupied the front seat, and so on. And when the bus stops at the destination, this person will be first out. Means the one who has come into the bus first will be out first. So we follow the principle of queue whenever we are standing in the queue in the banks, or when we want to get some service in the bakery and all these things. Wherever there is a rush, wherever there is a system of queue, we follow the principle of the queue. What is the principle of the queue? Queue has both the ends open. Through one end you can get into the queue, and through one end you can get into the queue, and through another end you can get out of the queue. The one who has come inside the queue will be out first. Means we'll get the service first. So the principle of the queue is first in. The one who has come first in. So it is FIFO. The one who has entered into the bus first will come out from the bus first. So the principle of queue is FIFO. So queue is the linear data structure which is having both the ends open. Based on that, the element which is inserted into the queue first will be out first. So queue is the linear data structure which follows first in, first out rule, while stack is the data structure which follows last in, first out rule. Now, how to implement the queue using array? Now we are going to discuss array-based implementation of the queue. Now, before that, let me explain different types of queue. In literature, 3 different types of queues are identified. One is linear queue, second one is circular queue, and third one is priority queue. All these 3 can be are implemented using array, and all these 3 are implemented using linked list. So implementation wise, logically concepts remain same. The only way that array is the static implementation, and linked list is the dynamic implementation. So when we go for dynamic implementation, when we don't know at the beginning how many elements we are going to insert in the data structure, we go for the dynamic implementation. And when we know how many elements we are going to insert into the data structure, then we go for the static implementation. Now let us discuss linear queue first and how it can be implemented using array. Now, making array to work like a queue means we have to maintain two indexes. Just how we made array to behave like a stack. So how we made array to behave like a stack? By maintaining one variable top. So what is the use of top in stack? Use of top in the stack is top is always holding the index of lastly inserted element. So by maintaining top, we can make array to behave like a stack. Similarly, in queue, we will maintain two variables. One is front. Similar to top in stack, we maintain two variables, front and rear. So let us try to understand what is front and rear. Front is index of firstly inserted element among the existing element, and rear is the index of lastly inserted element always among the present element in the queue. Now suppose this is the queue. This is the queue. Suppose it is having capacity 5. So which means we can enter 5 elements in the queue. So indexes are 0, 1, 2, 3, 4. So capacity of the queue is 5. So here I can write size of queue. Size of queue is 5. Now initially nothing is there in the queue. Initially nothing is there in the queue means queue is empty. So when nothing is there in the queue, then there is no question of front and rear. So remember what is front? Front is index of firstly inserted element. Index of firstly inserted element, and rear is index of lastly inserted element. So when there is empty, there is no first element and last element in this. So both are -1. Initially when it is empty, both are -1. So remember, when front is -1 and rear is also -1, then queue is empty. This is the only condition to check the queue is empty. Now suppose I want to insert A into the queue. Now where this A will get inserted into the queue? At index 0. So when A is inserted into the queue, it is having only one element. A is firstly inserted as well as A is lastly inserted, because A is only one element in the queue. So that is the first as well as last. So we have to indicate it over here. So front should also be 0 and rear should also be 0. So when you have front and rear both 0 or both same and both 0, it means there is only one element into the queue. So when you insert an element into the queue, you have to increment rear by 1. You have to increment rear by 1. Likewise. Now you want to insert B. Where the B should get inserted? At index 1. So it should increment rear, means from 0 to 1. So instead of 0 now, rear is 1. So when you insert the element, rear is incremented by 1. Rear is incremented by 1. So in stack, we incremented the top by 1, and at that index, the element is inserted. And in queue, rear is incremented by 1, and at that index, element is inserted. So here front is 0 and rear is 1. So a queue is having 2 elements. Now you want to insert C. So whether there are empty slots available? Yes, because 3 slots are still available. Size is 5 and only 2 elements are there. So we can insert C. As I explained you earlier, in every data structure, whether it is static or dynamic, before inserting the element, one must check whether that data structure is full or not. If that data structure is full, we cannot insert element into the full data structure. If the data structure is full, one cannot insert into the full data structure. Similarly, when we want to delete the element from the data structure, we must check whether that data structure is empty. So logically, one cannot delete from the empty data structure. So before inserting C, we check whether one or more slots are available. So here 3 slots are available, so we can insert C. So how can we insert C? Increment rear by 1. So right now rear is 2, make it right now rear is 1, so make it 2. Increment rear by 1, so make it 2, and at index 2 insert C. Now you want to insert D, increment rear by 1. So it is right now 2. Now it becomes 3. Now at index 3, insert D. Now you want to insert E. Similarly, increment rear by 1. So now it becomes 4. At index 4, insert E. So right now, rear is 4. Rear is 4 and front is 0. What does it mean? Lastly inserted element is at index 4. So rear always hold index of lastly inserted element. So among A, B, C, D, E, which is lastly inserted? E is lastly inserted. So that index should be present in rear. And among A, B, C, D, E, which is firstly inserted? A is firstly inserted. So its index must be present in front. So front always holds index of firstly inserted element, and lastly rear always holds index of lastly inserted element. Now here rear is 4 and size is 5. So there is no empty slot available. So now I can call that this linear queue is full. This linear queue is full because rear is 4 and size is 5. And we know the index starts from 0. So we cannot insert more elements into the queue. So for linear queue, what is the condition to check the queue is full? If rear is less than size minus 1, if rear is equal to size minus 1. If rear is equal to size minus 1, then linear queue is full. Now we discuss, now we cannot insert more element. Now I want to perform delete operation. Similar to stack, here also you cannot mention that you want to delete A, B, C, D or E. You can mention what you want to insert, but we cannot mention where you want to insert. See, in stack and queue, in both the cases, in stack as well as queue, in both the cases, we cannot mention where we want to insert, and delete. Index of insertion and deletion cannot be mentioned in case of stack and queue. It is automatically determined based on the data structure, whether it is stack or queue. If it is stack, then wherever is the top pointing at that index, it is inserted. And in case of queue, rear is incremented by 1 and at that index element is inserted. Now when you want to delete element from the queue, by the rule for the queue, the one who has inserted first should get deleted first. From A, B, C, D, E is lastly inserted and A is firstly inserted. So by rule, when you perform delete in the queue, A should get deleted first. So when A is deleted, B will become the firstly inserted now. So remaining elements will be B, C, D, E. So remaining element is B, C, D, E. In remaining element B, C, D, E, B will be firstly inserted and E will be lastly inserted. So what is the index of B? It is 1. So when you delete an element, physically you cannot delete the element. Physically you cannot delete the element, but logically you can delete the element by storing the index of next element in the front. So right now front is 0, make it 1. Right now front is 0, make it 1. So when front is having 1, it means this element B at index 1 is the firstly inserted, and when rear is 4, means E is lastly inserted. 4, this index 4 is lastly inserted. So the element at index 1 is firstly inserted and element at index 4 is lastly indexed. So this is logically empty slot. Even though you see A over here, this is logically empty slot. Now again we want to delete. So we have 4 elements B, C, D, E. Among B, C, D, E, which is the firstly inserted element? B is the firstly inserted element. So it should go out first. So when B goes out first, when B is logically deleted, then remaining elements will be C, D, E. So among these remaining elements C, D, E, which is firstly inserted element is C. So its index must be stored. Its index must be stored in front. So right now front is 1. So next front should be 2. So remember, when we insert the element, we have to increment rear by 1. And when we delete the element, we have to increment the front by 1. Now when front is 2 and rear is 4, which means that the element at index 2 is firstly inserted and the element at index 4 is lastly inserted. Means index 0 and index 1 are logically empty. Physically you can see some data over there, but logically they are empty slots. Now again when I delete C, next firstly inserted element will be D. Its index is 3, so that index should be stored in the front. So front should be incremented from 2 to 3. So D is, now you want to delete D, front will become 4. Now when front is 4 and rear is 4, only one element is there in the queue. Only one element is there in the queue, and that is the first as well as last at index 4. So when it is the linear queue, can we insert more element here? So what is the condition for the linear queue? Rear is equal to size minus 1. Still rear is equal to size minus 1. Rear is what? 4, size is 5, it is minus 1. So if you go by this condition, then it indicates that queue is full. But we know that 4 slots are empty. Still 4 slots are empty. But still it is showing that queue is full. So that is the drawback of linear queue. That is the drawback of linear queue. Even though there are empty slots in the queue, still we cannot insert more element into the linear queue. Means linear queue means it grows in only one direction. The queue which grows in only one direction, it is called as linear queue. Now to overcome this drawback of linear queue, we have to implement the circular queue. There is a circular queue. Now let us see what is the circular queue. Now in circular queue, what happens? Let me show you the concept. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 elements are there. Now this is front and this is rear. So initially it is empty, front is also -1, rear is also -1. Now you insert A, B, C, D, E. You want to insert 5 elements. So A should get inserted at index 0. So you have to make initially when you insert first element into the queue, you have to increment both front and rear. So you have to increment both front and rear initially when the queue is empty and you are going to insert first element in that. So in that case, you have to increment both front and rear and insert A at index front. Why you have to do this? Because when there is only one element in the queue, that is itself is the first element and last element. And remember, front holds the index of first element and rear holds the index of lastly inserted element among the present element. So this is the present element 1 and A itself is the firstly inserted and A itself is the lastly inserted. Then you want to insert B. Now by rule, when we want to insert the element, we increment rear by 1. So next rear will be 1. So at index 1, B is inserted. Then C is inserted at index 2. So increment rear by 1 and C is inserted. Then D is inserted at rear is equal to 3. So increment rear by 1 and insert D at that index, at index rear. See, remember front and rear both are the indexes, just like a top. When you want to insert E, E is inserted at index 4. It is incremented by 1 and at index 4, E is inserted. Now linear, it's a linear queue is full because size is 5. Because size is 5. And rear is equal to size minus 1. Rear is 4 now. Rear is equal to size minus 1. Now suppose we delete one element. Now insert operation and delete operations are also called as NQ and DQ. Insert operation in the queue is also called as NQ. And delete operation is also called as DQ. In stat, insert is called as push and delete is called as pop. In exam, you will be asked to write the NQ as well as DQ operation. It means NQ means to insert one element. You cannot insert more than one element in one NQ. Similarly, in stat, you cannot insert more than one element in when you call push function. So now you want to delete one element. So which element should get deleted? The one which is inserted first among the present elements should get deleted first. So among A, B, C, D, E, A is inserted first. So A should get deleted first. So in order to delete A, after logically deleting A, next first element will be B. Because remaining elements will be B, C, D, E, and among remaining elements B, C, D, E, B is the firstly inserted element. So that is indicated in front. So B will become next front. So front is incremented by 1. Now here you can see front is 1. Front is 1 means B is the firstly inserted element and rear is 4. So rear is 4 means B is firstly inserted and E is lastly inserted, and this slot at index 0 is empty. Means you have one free slot to insert one more element. So after E, when you want to insert Q, you can insert Q over here. After E, next element is inserted over here at index 0. Means after 4, next available index will be 0. After 4, next available index will be 0. And again after 0, next available index will be 1, then 2, then 3 and 4. After 4, next available index will be 0. So this is called as circular queue. This is called as circular queue. So why there is a circular queue? Because there is a drawback of linear queue. Because linear queue grows in only one direction, and circular queue, when it is full, again it comes back to first slot if it is empty. So what is the difference between linear queue and circular queue? If in linear queue, even though some slots are empty, we cannot insert more element. So we can go on inserting element. So the capacity of the linear queue should be very, very more. So with limited capacity, you cannot go for linear queue. So when you want to implement linear queue, you should have a very large memory, and it goes on increasing in this direction only. So A, B, C, D, you can go on inserting at these indexes only. You cannot come back and insert here if it is free. And when you delete, go on deleting from here. Even though these slots are available, you cannot insert at these slots. So this is the drawback of linear queue, which we have to overcome using linear queue. Now, when you implement it linear queue, right now rear is 4. Right now rear is 4. You can see rear is 4 E, and front is 1. So index 0 is free. Slot at index 0 is free. Now suppose you want to insert q, you can insert element q at index 0. So after index 4, after rear, when rear becomes 4, and when you want to increment rear, you can't make it 5, but after 4 it should automatically become 0. So see how rear should get incremented. When it is 0 and it is incremented by 1, it should become 1. When it is 1, it is incremented by 1, it should become 2. From 2, it should become 3. From 3, it should become 4. And after 4, it should become 0. So its capacity is 5. When its capacity is 5, after 4, it should become 0. And again from 0, it should increment it by 1 till 4. Again after 4, it should become 0. So in this way, rear should get incremented. And in the similar fashion, front should get incremented. So front initially should be 0, then it should become 1, then 2, 3, 4. After 4, front should become 0. And in this way, front and rear is incremented in the circular queue. Now let us see how we can implement this. How we can increment front and rear by 1 and make it circular. So the formula for incrementing rear is not rear is equal to rear plus 1. It is not straightforward incrementing by 1. So rear is not straight away incremented by 1. Rear is equal to rear plus 1. But instead we write it as like this: rear is equal to rear plus 1 mod size. Rear plus 1 mod size. If size is 5, it becomes like this. If size is 5, it becomes like this: rear is equal to rear plus 1 mod 5. Now when rear is 0, next rear will be 0 plus 1 mod 5. Mod 5. So it is 1 mod 5. 1 mod 5 is always 1. So when currently rear is 0, next rear will be 1. Because 0 plus 1 mod 5. Next rear will be 1. When current rear is 1, next rear will be 1 plus 1, 2. 2 mod 5 is always 2. So next rear is 2. And so on. So when rear is 4, when current rear is 4. After 4, what will be the next rear? So it's going to be 4 plus 1. Next, according to this formula, if current rear is 4, by this formula, next rear will be 4 plus 1. 4 plus 1 mod size. Mod size. Size is 5. So this 4 plus 1 will become 5. 5 mod 5. 5 mod 5 will become 0. So remember here, when currently rear is 4, next rear will be 0. Next rear will be 0. Similarly, you have to make this arrangement for front also. Front is also incremented in the same fashion because it is circular. After last element, rear should point to first index. So front is also incremented in the same fashion. So next front is current front plus 1, current front plus 1 mod size. So when front is 4, next front will be 4 plus 1 mod size, that is 5. So it is going to be 5 mod 5. So next front will be 0. So this is what makes Q as a circular Q. Now let us see how to implement circular Q, NQ operation. NQ operation. Now you have to define the structure similar to the stack. In stack you have a structure stack. In Q you have a structure Q. In Q you have a structure Q. In structure Q you have one array inside that, and there are front and rear, 2 indexes. In array, in stack, in structure stack you have the array and you have a top. You have it when you have a variable top which indicates index of the lastly inserted element. But in Q you have to implement this structure with name Q. Inside this structure there is an array which actually implements Q, and there are 2 variables inside this structure. One is front, another one is front, another one is rear. And this structure address you have to pass to NQ and DQ, because in NQ front and rear are changes. You cannot pass this structure as a value. You have to pass address of this structure. So you know when to pass address and when to pass value. So whenever you want to do the changes in the function, and that changes must be reflected in the calling function, then you have to pass the address. Means this is call by reference. So Q variable, the Q is the structure, and its structure variable you have to pass by address. Means address of the structure variable you have to pass, and that is to be collected using pointer. And using pointer you have to access the array and front and rear. So let us see here implementation. So this is a linear queue. Now this is circular queue. This is an array A. You can implement it using array, or you can go for structure. So in this case, array is used. So in this case, you have to pass address of front and rear every time, or you can make it as a structure. In that structure, you can write array A and front and rear, and you can pass only one structure. Both are same. So instead of insert Q, you can write NQ operation and DQ operation. So both logic can be implemented. So here if we don't implement the structure, means inside the structure we have to write A, front and rear. If we don't have the structure, then each of these elements should be separately passed. You have to pass A separately. You have to pass array by reference. Means all arrays are passed by reference. You have to pass front and rear by reference. So more number of parameters will be there. But if you make this as a part of structure, then you have to pass only a reference of the structure, just how we did it in the stack, and you have to pass only element. No need to pass these 4 parameters. Now see, if you see the logic of the circular queue. So before we have to check queue is full. So when the queue can be full, there are 2 ways in which queue can be full. Max means size, maximum size. So when see here, reference is passed, that's why we are implementing start. So when rear is max minus 1 and the front is 0, when rear is max minus 1 and front is 0, see here. So there are 5 elements. There are 5 elements A, B, C, D, E. And max is 5. Max means size. Max is 5. Means maximum 5 elements you can have. This is front and this is rear. So rear is 4 and front is 0. So what is this condition? If rear is equal to max minus 1. Max minus 1. So what is max? 5. 5 minus 1 is 4. So rear is 4. 4 equal to 4. This condition is true now. And further, front should be 1. Front should be 0. So when front is 0 and rear is max minus 1, then the queue is full. This is one way of queue is full. Another way of queue becoming full is, suppose you delete one element. Suppose you delete, in this case, one element. So which one should get deleted? A. So next, after deleting A, next front will be B. So in this case, front is 1 and rear is 4. Rear is 4 and this is empty slot. Again, when you want to insert one element, after D, after E, you want to insert F. So F should get inserted here. So rear will get incremented by 1. So rear, right now it is 4. It will come here. Rear will come here. Rear will come here and rear will be 0. Rear will be 0 because it is circular. After 4, rear comes here. So rear is 0 and front is 1. Rear is 0, front is 1. So rear is 0, front is 1. Means F is the lastly inserted element here and B is the firstly inserted element, because A was deleted now and F is inserted here. So F gets inserted here. So among B, C, D, E, F, F is lastly inserted and B is firstly inserted. So when you see the position, rear is 0, and front is 1. So when rear is 1 less than front, so when rear is 1 less than front, so this condition is written like this: when rear is equal to front minus 1. Front minus 1. So here front is 1 minus 1, it equal to rear. So rear is 0 and front is 1. So both condition is true. So this is also the condition which checks the queue is full. So same thing is written over here. So rear is front minus 1 or rear is 1 more than front. So that condition needs to be modified over here. So rear is front minus 1. or front is rear plus 1. Likewise, both are same thing. In that situation, Q is full. So if you go by this logic, whatever we have seen, same thing is implemented in this code. If it is full, then the message is displayed. If it is not full, then check if rear is equal to max minus 1 and then make new rear as 0. So make it circular here. Make it circular means if rear has reached max minus 1, make rear 0 and at that index insert the new item, or increment rear by 1 and insert the new item. If front is minus 1, then front and rear both are minus 1, then increment front by 1. So this code, I will share this code with you. Another way we can implement this logic. Another way we can implement, and I will share with you the code of this Q. So with this, we stopped today's session. So I request all of you to write what are discussed in the today's session. What are the today's session key takeaways?